Hi, everybody. Thank you very much. We are going to do warm-ups number 8 and 9 today. And the directions for number 8 are to find the mean and sample standard deviation for each data set. I already found the mean to save us time. Do you guys know how to find the mean? Okay. Also, do you know where these numbers came from? Yeah, so this is 74, 74, 77, 78, 79, 80, 80, 80, 81, 82. And I want to prove to you that I did this. So I added up all of the numbers in my calculator here that were in this column. And then I saw that it was divided by 10 because there's 10 numbers. Shh. And that means I moved the decimal point over one spot and my mean is 78.5. Do you have any questions about how I got the list of numbers or how I got the mean? Are we sure we're clear on that? Okay. Sample standard deviation has, I forget how many steps. 6 steps. But I already did step 1. So step 1 was to list the numbers in a column, which I did. Step 2 is to subtract the mean. So minus 70, already messed up. Minus 78.5 minus 78.5 minus 78.5. Okay, to do a problem like this, I'm going to use this lovely machine I have here called the calculator. 74, that's supposed to be funny. 74 minus 78.5, I did it right here because I was starting already, is negative 4.5. Which is the same answer here, negative 4.5. 77 minus 78.5. I know that one in my head, but do you guys have any questions about how I got step 1 or 2? Step 1 was write all of the numbers in a list in a column. Step 2 is subtract the mean. Does anybody remember step 3? You can look back at your previous example. Square. It's yep, square, and then add all of them. Now, remember to put parentheses around the negative ones when you square. Because the whole purpose of squaring them is to make them positive. Because in stats, we don't like to work with negative numbers. Bless you. Sorry about my location on the paper. I just the dot plot started bugging me. Uh-oh. Okay, so let's review. I wrote the numbers in a column. I subtracted the mean. I squared them all. I added them all up. And now I divide by how many there are minus 1. How many are there? Thank you. Notice in the calculator, I just did divided by 9. And then last step is square root. .7588. You are going to have a chance to do this in your groups today. Do one of these. So I'm gonna do another one with you, and then you're gonna do one, which is one of the reasons why I think we're gonna run out of time, is because I want to give you plenty of time to actually do it properly. So, okay, so just reviewing. Step 1, list the numbers in a column. Step 2, subtract the mean. Step 3, square all of the numbers, making them positive. Step 4, add them all together. Step 5, divide by however many there are minus 1. Step 6, square root. Okay. Now let's move down to number 9. I wrote it for you already. Pretend that it's equals. All inequalities start the same way. Step 1, pretend it's equals. Okay, what do I do first in an equation like this? It starts with a D and ends with distribute. Distribute. Okay, now I'm going to combine these two. Okay, I always like to start by undoing the lowest thing with a letter on it. Okay, step 1, pretend it's equals. Step 2, solve. Also in step 2, rejoice in the fact that -4 is a value on your number line. That means you probably did it right. Okay, now we're going to plot the point open or closed. Is this one open or closed? Open. And now we're going to test 0. And 0 is going to be right here. So we're going to test this spot to see if it's true or false right there. So -2, 1 minus 4 times 0 plus 6 is greater than 3 times 0 minus 16. Okay, let's go through order of operations. What's -4 times 0? What's 1 minus 0? 1. What's -2 times 1? -2 plus 6, 4 is greater than -16. True. So that means this is true. And we want our arrow to go toward the true. Arrow always goes toward the true. Shading always goes toward the true. Okay, last step. Everyone always forgets. Final answer. B is greater than -4. Okay, I think we're done with the packet for the moment. I think, yes, we're done with the packet. I do want to show you the joke because this is the last joke of the year. So let me find it. Are you guys ready for the last joke of the year? Okay, today we're doing, it looks like only 4 problems, but they're long. They're all long. It's long. The whole thing's long. So homework is 68 to 73, and here's my last joke of the year. Do you see that it's pi? Yeah. Okay. All right, I'm gonna give you several minutes to set this up. Force yourself to do it. You're super close. Just remember, this is the last lesson from the book. You what? No, well, we're doing the review notes on the block day and then just the final exam review packet, then we're done. This is the last thing we're learning.
But weren't we gonna be able to get the test subjects so we can start looking?
Oh, they should have posted today. Let me check.
Okay, I just haven't checked.
Let me check to make sure it actually did though. I have it all written. I just don't know if I, but you can, I'll look at that. Well, are you already done? Oh, I know I haven't. Here it is. Okay, it's posted. Thank you for reminding me.
I've just been having like kind of some trouble with the probability of stuff. It's not really making sense to me.
Okay.
So I just kind of want to make sure I'm ready.
Hey guys, so today, um, there's a lot, I told you, I know it's a lot. But it reviews basically everything that we've learned from stats so far. So what this is it's a comparison of two different sugars. I'll review the problem in a minute. But what it's going to review is how to find the min, the max, the median, quartile 1, quartile 3, standard deviation, and then how to find IQR and decide if you should use median and IQR or if you should use mean and standard deviation. We did that in notes, but today we review it all again one more time. And that's everything that we need to know from stats. Now, Daxton had a really good point. He said something about probability. That's completely different. That's the two-way table stuff, which we're going to review again Thursday in the review notes. We'll do another one where we make a two-way table and do probabilities. That's separate from this. So stats is like the number crunching stuff. Probabilities is when you have the two-way table and you're doing like blocking out a column or whatever. I think the probability stuff is much harder than this. Personally, I think this is, just kind of, I don't know. It's just kind of a procedure. But the probability stuff is harder. Anyway, okay. What our goal is on these two problems. So let me show you the book real quick so that you can see the context of what it's saying. It's saying A biologist is trying to determine which sugar is more successful in growing a particular. Can you tell me how to pronounce this? Nice. So she collected the data below and the diameter in micrometers. Okay, and note that the biologist wants to grow consistently large cells. So the biologist wants them to be big. Can you tell which sugar is probably better if she wants them to be big just by looking at it? Sugar W or sugar P? Which one tends to have bigger numbers? P. Okay, so our gut tells us that sugar P is probably better. Okay, first thing we're going to do is the 5-number summary. So I want to go a little bit slow. The first thing I want to calculate, I'm just working on sugar W at the moment. What is the minimum? 10. This is called the 5-number summary. What is the max? 70. Okay. Now, the next thing we want to find is the median. There are 19 numbers. So which number should be the median? The 10th. Okay, or you can do Mrs. Talbot's fancy counting in technique. This number right here should be the median. This is the 10th number. So the median should be 40. Okay. Now, to find quartile 1, you ignore the median and count in. So count in, count in, count in, count in. The middle number here is 34. That's quartile 1. Ignore the median, count in, count in, count in, count in. Quartile 3 is 45. Do you guys have any questions about where I got the 5-number summary from? Does it make sense how to get them? Also, if you count in and there's 2 numbers, what do you do? Yes, add them and divide by 2 or find just the middle of them. Okay. Next thing we're going to do is the box plot. And we're going to do the box plot right here in this little extra space. The box plot is going to start at 10. So draw a vertical line at 10. Then 34. Then 40. Then 45. Then 70. So my 5-number summary becomes the 5 vertical pieces in the box plot. You connect the middle 3 to get the box. And then connect those to the outside to get the whiskers. Do you have any questions about how to get the box plot? Did I do okay? Okay. Last thing we're going to do right now for this is the histogram. And notice this says right here 0 to 9.9 repeating. So anything from 0 to 9.9 repeating goes here. And this bin is going to be 10 to 19.9 repeating. How many numbers are between 0 and 9.9 repeating?
1.
0. There's no numbers between 0 and 9.9 repeating. How many numbers are there between 10 and 19.9 repeating? 1. So my histogram is going to be 1/12. That's this 10 right here. How many numbers are between 20 and 29.9 repeating? 0. How many numbers are between 30 and 39.9 repeating? 8. How many numbers are between 40 and 49.9 repeating? 9. Yeah, don't forget that 40 that I circled. Okay, and this last one is 70. This is the biggest question right now. Is the 71 going to go in bin 1 or bin 2? Bin 2. Okay, I would like you to take a few minutes in your groups to repeat this process for sugar P. Find the 5-number summary, find the box plot, and the histogram, please. Definitely talk about it. Yeah. Did you not? Yeah. Oh my goodness. I did it. I did the wrong spot. By the way, I'm gonna show you what I have. If you could just ignore the extremely large amount of whiteout that is underneath my box plot. I accidentally did the box plot here and it wasn't lined up with that one and I thought it looked really ugly. No, it doesn't matter. I just didn't like it. Because I'm weird. But no, it doesn't matter. Okay, check your work, check my work. What do you think? I'm used to it, don't worry. Okay. So we're going to describe them in a little bit. But this one, I would call this one roughly symmetric with outliers. That and that. Then I would call this one uniform with no outliers. Does that make sense? Yeah. Okay, so just making sure we're on the same page. We're gonna write that stuff later in the problem, but before I move on from the graphs. Any questions or anything about how I got any of this? Okay, so we're solid on the stats part. No? Yes. Okay, now B is to find the mean and the median of both sets. We actually have the median already. What was it in micrometers? It was micrometers, right? Yeah, that's the sugar diameters. I believe these were in micrometers. Okay. So let's talk about how to find the mean of this data set, and then I will have you guys do this one. Okay, I'm gonna do it in a calculator. 10 plus 32 plus 32 plus 34 plus 34 plus 36 plus 37 plus 39 plus 39 plus 40 plus 41 plus 43 plus 43 plus 44 plus 45 plus 46 plus 46 plus 49 plus 70. Whew. I hope I did that right. Okay, divided by 19. Now notice the reason I did this was because you need to do this in 2 steps in the calculator. You have to add it all first and hit enter, and then divide by 19 and hit enter. So the median of this set is 40. And the mean is also 40. They're both 40, which is interesting. But that happens when you have symmetric or uniform data. The mean and median will be really close to each other. Okay, I want you guys to find the mean for sugar P, please. you start that, please? Gosh. It's 40. Did you get 40? Yeah. Okay, so this is a really interesting question. If the mean and median are both the same, how can we tell them apart? There are two things that we can use to tell them apart. Actually, three things we can use to tell them apart. So for C, I'm going to say the center is the same. The mean and median are both 40 for each set. How can you tell the sets of data apart? What's the first way? There's actually three ways. Yes, outliers is one of the ways. What's another way? Shape. And what's the other S? That's shape. You might need to look back in your notebook to see what the second S is. No. No. Just flip your notebook back one page. Spread. Okay. Okay, now outliers are easy kind of for us to see. Shape is kind of easy for us to see. Spread, there's a bunch of different kinds. And so we're going to talk about spread in number 61. One way to measure the spread of data is to calculate the range, maximum minus minimum. What range of cell sizes did each sugar grow? Why is the range often not a useful measure of spread? Okay, we're going to do it, then I'm going to tell you why it sucks. Okay, so range equals max minus the min. We only have to calculate it once because both of the sugar data sets have the same max and min. They both have 70 and 10, right? $70 and 10. Did I get it right? Okay, now why is this not super useful? Why is range not super useful? That's true, but okay, scooching up here, this is 10 to 80. It's actually 10 to 70. This is 10 to 70 here. Is the range really going from, okay, let me ask you this. Are most of the numbers really in between 10 and 70 on both of them? Where's most of the numbers in this one? 30 to 50. Okay, what are these called again? Yeah, so the range isn't useful because it includes the outliers. So you don't really know where most of the data is. Okay, for B, we're going to do socks for both graphs, and we're very lucky. You'll see why in a minute. Okay, the first S stands for shape. What is the shape for sugar W? W. That's this one. This one is uniform. What's this one? It's called roughly symmetric. Okay, does this one have outliers? Sugar W? Yes. And what numbers were our outliers here and here? If I go back up to the data set, what numbers are these two boxes in my histogram? Yeah, 10 and 7. Does the uniform graph seem to have any outliers? No. And it's totally okay to write none there. Actually, it's better to write none there. You don't want outliers. Outliers are bad. Okay, now I'm going to flip back to the notes really quickly. In our graphs, do we have any skew or outliers? Did I not just name what outliers? Okay, so if you have skew or outliers, you need to use median and IQR. That's why we got lucky, because we don't need standard deviation at the moment. Okay, so the center is going to be the median, which is 40 micrometers, I believe. And if you're comparing two graphs, you have to use the same statistic. And spread. Anybody remember how to get IQR? Perfect. Q3 minus Q1, so I got to scroll up. 45 minus 34. Okay, according to the IQR, which set of data is more spread out, sugar W or sugar P? P, right, because the IQR is bigger at 30, which means it's got a greater spread, so it's more spread out. Do you have any questions about how I got this stuff? You sure? Yeah. Sure. You should really wait till Enrique gets back, though. I don't know when that's going to be. Could be any minute. Could be any second. Actually, you should go because it's 10 minutes before. You should go quick. Okay. Now this is it's already 3:25, which is just crazy to me. Okay, this is the last thing. You know what we're going to do. Okay, this is the second to last problem. You can tell I'm gonna stall out here because we only have 10 minutes left. So what I'm thinking is this is going to be the standard deviation. I'm gonna do W with you, and then I'm gonna have you do P in your group. If you need to start it when you get back on the block day, that's fine, but let's try to get as far as we can on W. Okay, what's the first step? What do I do first? List the numbers in a column. Already screwed up, already screwed up. Okay. All right. Step one, list your numbers in a column. What's step two? Subtract the mean. What is the mean of this data set? 40. I like how my handwriting's all like perfect at the top and then okay, do you remember what step three is? Square. Okay, now do you guys all trust me enough to have done this on my calculator before you got here? Do you know what the next step is? Add them all up. Do you trust me to have added them all up correctly? And what do I divide by? 19 minus 1, right? Last step is to square root.